Hello and welcome back to the stream. I'm Junchan, and well, here's my face again. It's been shown on screen before if you've been following, but yeah, it's a slightly different setting. I have a green screen, microphone. I yesterday my devoted follower one mentioned that my sound was a little bit crappy, and I gave the excuse that I had it with my sound setup. And then thinking about it, I realized that actually I could leave my sound setup over there and pull cables in a way that would actually allow me to have this lovely microphone. And then since I was at it, I thought, okay, well, how about I bring the camera and set up the green screen? And so, yeah, so I got all the things. And yesterday I showed you this mosaic screen, and now it's maybe a little bit more focused and a little bit all over the place, but it still has a lot of the good stuff. So it has paper and pen. It has my control screen here where I have OBS and the stream manager, and my coding screen. And so actually, if I go in studio mode, I can show you some of the other stuff. I've got the browser coding with my face on it. I've got drawing with my face on it. I've got actually my music workstation, which is running Ableton Live, which is doing some audio processing. Think the audio is okay. I didn't listen to it carefully with headphones with the recording, but it's probably much better than the crappy USB stuff that I was using before. And yeah, we still have the sky. I think it's the sky live, but it could be that it's not. Yeah, so mosaic is pretty. I've got also screen, the control screen, again with my face on it, and I've got the be right back and the bye bye screens as usual. Okay, so why am I back? Well, I suppose maybe mosaic might be good here. Yeah, so this morning I was thinking about some of the stuff that came up on yesterday's stream, in particular with the extensible ADT library that's part of this Haskell system for Haskell for Linux systems, I guess you could say. And yeah, that stuff's super inspiring. The extensible ADTs and the variants, that's part of the stuff that actually starts connecting dots for me in terms of what I was also looking at with PureScript and things like PureScript run. So also using base functors, but also to build up more flexibility and deal in some sense with the expression problem, which is also what the Haskell folks reference as one of their guiding motivation there. Expression problem in a nutshell is the ability to be able to make more composable chunks of programs where if you define a data type and some behavior in one file, for instance, you won't, if you add a new behavior, you won't have to also change something in any of the other files that are part of your program. It allows things to be more modular. And with the expression problem in particular is with the definition of a grammar for a language and the ability to extend that language without having to, without the ability to be able to write the new capabilities in sort of an isolated modular fashion. And well, so that stuff is obviously great. It's a level of abstraction that can hurt the brain, but that's a good thing, right? And well, so it's led me to think a bit more about this like huge potential rabbit hole about basically data structures and more generic data structures. And I've spent a lot of time in the past few years looking into this and trying to bridge the gap between, sort of old knowledge about things like entity relationship approach, relational schema, some of the new stuff that I just beginning to grok around the original relational algebra and how SQL and so on departed from it in some ways with null values and whatnot. And the fact that the relational algebra had this nice composability built up, and this idea of also of like a certain approach to type safety as well, or which would avoid having null values and things like that. And there's some interesting projects in that space, like Project M36 in Haskell, which is a database built from the ground up in Haskell with the relational algebra in mind, and a tutorial D interpreter, which is, And then there's this whole sort of connected environment with data log and logical programming and so on. And then in another bucket, and there's not a lot of connection between it, and it's something that I've also spent quite a bit of time looking at, there's the whole semantic web and knowledge ontologies, RDF schema, OWL, description logic, and then all of these things sort of, there are some papers that actually aim to connect those, like particular, some of the stuff from David Spivak working on the categorical databases that to me really started connecting the relational model with the RDF approach. And then there's this whole sort of somewhat connected all other ecosystem, which is around the technologies like Datomic, which is data log, but with a little bit more of an event-sourced approach, where there's this approach of being able to add basically quads into the database, and this approach that connects to the event sourcing community, where and this whole this paper that turning the database inside out, this notion that instead of hiding the log and where most of actual databases sort of do their read-write logic, and then providing this high-level abstraction to do queries and so on, mutations and queries. With turning the database inside out, you sort of make the log a first-class citizen again, and that gives you things like basically time traveling capabilities in your database. You're able to roll back because you can just go back in time with the log. And then with Project M36, there's actually a connection with that, but it's even like a graph with forking and whatnot. And that connects in turn to this idea of CRDTs, where you send operations in something you could see conceptually as a log, and then there's the logic of how particularly concurrent or out of order operations or conflicting operations are dealt with. That's all part of the CRDT algorithm. And so when we're looking at Chronofold, we see a particular point in the data in the solution space for this, which is dedicated to text, that is aimed to be highly efficient on the wire and in memory for text rendering and text manipulation, including things like ranges and whatnot, but also deals with the merge conflict in a way that's also relevant to text. And I would say here the UX aspect is this idea that, well, if it's okay if, because people were inserting at the same place, that's it. Like there might be some kind of, as long as things kind of stay in a block and they're the same in all of the workstations or the agents that are working on the same text, then it's acceptable, because if they're connected at that moment, then they will see that there's someone else is maybe writing the similar thing around the same place, or do a bit of formatting in order for these things to actually work in the flow, like moving things around or whatnot. But so these guarantees or this point in the design space is well suited to basically online text with a certain short feedback loop. If you start looking at editing offline, even though it is the possibility within the CRDT, then I would say maybe the interface then is not ideal, because it could be that you're so far behind, or the text that is added to your screen is added because someone that was offline for a long time just pops up and then sends their text changes. It could be then that you actually want to give some control to the users about what's going to happen then. And that's something that is another point in the design space where maybe merges and decision on conflict is not necessarily automatically solved because the UX is meant to be with these short feedback loops. And so in that case, you might need to actually ask the user for some decisions. So that's a bit of some of the questions that I've been sort of asking myself. And then what comes with this, and a follow-up from yesterday's sort of early data modeling session around these audio tracks and audio sources and routing, describing routing, started prompting again this idea that, well, I should start to look at how I'm going to persist the data, because you will want to be able to open a scene at some point that might be lying somewhere on your hard drive, and it will have the proper inputs connected to the proper outputs, and then you'll be ready to sort of do the smart live things and whatnot, right? So serialization and persistence of the data so that it can be loaded up, and then you can then modify it. That's the traditional sort of like opening and saving files model. But since I'm interested in a kind of a more distributed setting, then arguably you can ask, well, actually maybe this secret, and again, like the event sourcing, turning the database inside out concept, right? Maybe these audio tracks definition, how they connect to inputs, how they're routed, maybe each of these are actually events, which in fact are they're data events, right? They're in fact the expression of some manipulation of existing data or of some existing data structure, if that data has some kind of schema of some type. So here I'm adding a few other layers, right? Now we don't just, we can be loading something, but we're loading it maybe from an event log instead of from a file, a specific file. The event log might be in a file, right? That's all good, but it could be also that actually this is being streamed to you. So you might be receiving it not in a batch, loading the file, but you might be actually, maybe you open the file, but then you continue receiving it in a case, for instance, where either you have several machines that are meant to be displaying the same data, operate with the same assumptions about what the routing is like, for instance, which might be the case if you delegate some routing between some machines, and you're even describing not just routing inside streams that go inside one machine, but streams that are actually distributed between several machines, right? If you describe something like that, then you might want each of the machines to sort of have the description. If I'm on one of the machines and I say something that means that another machine would need to wire itself differently, choose a different audio input or something, then I want all of the machines connected to that swarm to know that that's the case. So here it looks like event sourcing, and it looks like a CRDT, right? It looks like one machine will emit an event that will be sent over the network, received by all the participants in this particular domain-specific swarm, and then that event will have some semantic meaning that will that can mean several things. And that's interesting also, because in the event sourcing community, there's two main things that that can be represented by an event. And there's always a tension also. An event is either some data modification or it's a command. And in that case, it's just asking some service to usually do some side effect, do some mutation or something. And so I don't think this abstraction is necessarily super clean in the, but and I think the fact that a lot of people have questions about, oh, should I put my commands inside my event bus or should I have a separate event bus? And then the fact that when you have issues of sync or coordination between services around commands and events, then it starts getting really unruly. So I'm not sure I've quite conceptualized what the actual solution to all of this is, but I'm striving to maybe in some sense simpler model where maybe this difference doesn't necessarily mean much. And I think that when you look, for instance, at this approach, where I was thinking about the free monad-based functor representing a state transition, a kind of an action, and the interpreter, the co-free comonadic interpreter, that this represents a state change in a state space. Then I think you start having basically the same ideas, but maybe slightly more grounded and more maybe more explicit, because now you can have events that maybe create state transitions in things that are not inherently linked to persistent state and things that are inherently linked to persistent state. And these would be maybe independent DSLs. And so what do I mean by that concretely? I mean some things like, basically I mean that they should, like, there's things like transient event that don't represent a necessarily an actual change in data that you want to persist on all machines connected to a swarm, for instance. It could be that, and here's a way that it could be like switching gears. For instance, if I want to, let's say I wired and instrumented all of my tooling so that anything I do on screen live is outputted as a metadata stream. Then it could be that we're basically, if you're hooked into that and you have read-write access, then it could be that if we're actually really sharing the session, if you click on file, it will actually open the menu, and I will see that. And maybe we'll have several cursors flying around the screen or something like that. That's one very deep level of synchronization where everyone is kind of persisting the same and operating on all of the events. But you could decide that my mouse position, you don't want it to be persisted, or I could decide that I'm not sending it to you as well. And then in that case, it's just transient states inside my local machine, and you're not receiving it. And so in that sense, and it could be also that I send it, but that you're not using the data. For instance, maybe I could see your cursor, but I don't listen to your clicks, which is an interesting thought. Then things might be diverging at some level, but I guess there's a way to put that cursor at different level of fully synchronized, persisted data that's evolving in sync on all participants of a swarm, or things that are less that are not meant necessarily to be persisted. So, for instance, you might receive all of my mouse positions and all of that what I opened and all of the key presses that I did, but you might not persist any of that. You might just be consuming it to display and operate or animate a visualization that allow you to see what I'm doing, but you might not be storing it but you might as well be storing it. So in that case, then every action in some sense can become either a command or an event in the event sourcing way. But I won't go too much on the event sourcing thing, but it really animates my thinking. So, okay, so that's one approach. So for audio tracks, for instance, and routing, what I would want is obviously what I want is that whatever I do for this particular application scales and works for many other applications that I would write with this framework, and that they actually share an event bus, and that so that there's some meta schema that would work for all applications, a bit like dbus, I would say, maybe, but maybe with more expressivity, and specifically maybe more type level facilities or something like that. And so so this whole variant thing made me realize, well, and also there's a whole other domain that I need to talk about shortly, which is the one from the live programming and some of the stuff that Turian, the author of Rhine, the type level clocks in functional reactive programming, has been working on. And one of the things he's been working on is the essence of live programming. He's been looking at this idea of data migrations. And data migrations is also something that I've seen an amazing talk about from Andreas Lowe, who is the author, I think, of the generics SOP library in Haskell, which is one of the frameworks to describe generic data types. And well, he did this talk on SOP applied to data migrations, how if you have a meta language to describe all your data types, then you can augment it with a language of how you added a new constructor to a data type, or how you removed a constructor from a data type. Since SOP, in a nutshell, basically is an abstract way to say, well, okay, if I have list equals nil or const a list, then list is actually a sum of nil and const a list. And const a list is actually a product of a and list. And so defining sums of product, that way you have a generic representation of any algebraic data type. And so you can imagine that it's quite useful to have as is, actually allows to do things like deriving instances automatically for your complex data types. But since you have that language at hand, it's really a kind of a DDL, a data description language. And if you augment your DDL with some primitives to explain how you're modifying an existing DDL, then you have a migration language, and you're able to do schema migrations and describe how your data type evolve. With the essence of live programming, that goes even a little bit further, because then you even want to be able to derive from your schema migration a data migration. And so, which you usually want in a lot of settings for enterprise programming. You usually want, if you do a schema change, to have a data migration associated to that. And sometimes you can maybe derive one automatically if your DDL migration language includes things like setting defaults, for instance. So if you say, hey, Crazy Pickle, thanks for the follow. If you have something like a constructor, and that you want to add, yeah, my dude, happy Sunday to you too. Hope you're enjoying, having a good time. I'm blowing my head with some abstract programming thoughts, and I enjoy it a lot. So yes, what was I saying about the DDLs and the migration? Yeah, if you have say the nil or const A, and then you say you want to add nil and nil2, then you can automatically migrate everything, because a sum type, a change in a sum type, as long as you don't modify the existing constructor, is actually not going to hurt any of your existing code, which is actually really also what variants are about, because variants have this ability to do pattern matching on things that might have changed underneath you, which is, again, fairly similar to how you would do generics programming. But I think variants might be, but yeah, I haven't programmed a lot with this concept yet. I've read a lot about them, and I do want to make the rubber hit the road by practicing with them more. And so this is a great this idea with audio tracks and routing is a great excuse to get better at them. So right, and then if you have a product type, then adding a new field, if you specify a default in your DDL migration language and say, well, I'm to my const A list, I'm going to add const AB list, but you say in your data migration language, and B's are by default true. Let's say B's are Booleans, right? And so if you have this piece of information, then you can migrate all of your application, all of your instances of application of everyone around by just saying them, hey, change your data type const A list to const AB list, and all your A's you keep them, and your B's just add true in there, and and then now if you receive B's, you're able to process them. So there's a whole number of interesting, difficult topics around whether you keep backward compatibility or not, and all of that stuff can get pretty hairy to and I think usually you want them to be fairly tight and formally verified, because your data usually is super important. So you want to make sure, and so that, I think when we get to that part, I think we are going in the direction of functorial data migration, and like this work on categorical databases and ways to specify very precisely what data migrations look like. So again, something that I've read a little bit of papers about, but I haven't really experienced. And but this community is part of the applied category theory community, and you will see much more amazing stuff coming out of that. Topos Institute, amazing stuff. And I mention all this because, as you'll see in the in my morning design session, some of that stuff was definitely popping up in my head. So let me rephrase my the topic here, and maybe I'll write it down on. Well, we're not Saturday. Let's say that it's unscheduled, right? What we're doing in this stream right now is thinking about the data schema for a generic event-based, let's say a schema, schema for a generic event-based distributed data well, maybe a data language in some sense. And why do we need that? We need that because that's the way in which I want to concretely basically save my sort of, my how I call it, like SL Zilla, right? So save my SL Zilla. Well, actually, we have a name for it now. It's called Streamline. So save my Streamline scenes, so which is kind of a serialization and persistence problem. But also I want to share my streamline scenes in real time. And that's also serialization, but that's kind of event, well, that's event sourcing, but also CRDTs. And bonus points is, well, obviously I want it to be generic. Generic, so I can reuse it elsewhere. And with this idea of the expression problem, I want to reuse it, but I want to minimally have to modify anything that's existing, that's already attached to this infrastructure, that's already subscribed to these events, or yeah. So I should say something about the event sourcing part, because that's something I haven't necessarily said before. This idea of projections basically coming from event sourcing. Basically, my event schema, my event format won't necessarily be that optimized in terms of a database log or even a network protocol. I want it to be tight and pretty, but I'm not going to focus on that. I'm going to focus essentially more on expressivity and correctness at the beginning, and thinking that if I want things to be performant and be really fast, then in fact it's going to be a matter of subscribing to a particular set of event types and materializing it in a projection, which could be a relational database and have fast queries and whatnot. Or a graph database that also is able to do, shortest path and like smart click calculation things, or a tightly packed arrays or structures of arrays, or structures of arrays of structures of arrays that are meant to be in the GPU for, fast texture loading or geometry loading, if we want to do high performance stuff on the GPU, for instance, or on the CPU. So I think of these as projections, or you could say derived data structures. And so that's not part of the design constraint for this generic event-based distributed data language, because I can be fast just right after that. So I think whatever is processing these events I see it as a kind of a runtime, something that is fairly low level, and like is able to listen is able to get a low level handle on a network interface, and fork processes from it, spin up fork processes from it. And so Haskell seems like maybe it's going to be amazing for that, especially if I can do things like spawn new processes, even power off the computer. I mean, that's super amazing. And then even further, I think, I'm not putting this right now in my bucket of things that I'm thinking about as part of the design. But as you'll see when we get to my morning notes, in fact, I am definitely designing with that in mind. So it's not going to just be a distributed data language. It's really a distributed programming language. And so in that sense, it will, it's probably, I don't think it's ever going to be that, but it's at least because there are some folks in the ecosystem, and I'm thinking specifically about Unison, that have done lots of amazing work, and it makes more sense probably to piggyback on that work for distributed computation and things like content addressable computations, and so definitely lots of inspiration to take from that. But the reason why I'm thinking about this is because and it's a bit of a stretch goal, but it's fairly, when you look at how a compiler is written, then and which, when you start learning about Haskell, at some point you start reading a lot of toy compiler code. Then it's basically just abstract data types. It's basically just data structures, and most of these things are like the expression problem and making things modular come from the programming language community. And so once you have a way to describe things like an audio track and how it routes, that's all good. Like that's just data, right? But you're very close to being able to say, well, actually, how about my routing is dynamic, i.e., it's a computation, i.e., it has some rules associated to it. Depending on the time of the day, the routing is going to be done differently. So then your data type is not inert data anymore. It's a computation, and that's something that's duality between data and computation that's fairly also pervasive in the functional language community. In fact, I had this thought, which is probably an existing well-known thing, but how how the church calculus is a sort of a dual of the Turing machine, but what's interesting is that church is kind of computation biased and Turing is kind of data biased. I'm pretty sure I've read this before, and so it wasn't a new original thought, but it came back up to my mind. Like this, Turing is data driven because everything is based on this tape, and your code is on a tape, and you go and fetch the code that's a data structure, and it tells you how you're going to move that tape and whatnot, right? So, but it's data first, and then some computation kind of second, right? Whereas church is actually computation first. It's like lambda based, which lambda, the essence of a lambda is you give me something and then I give you something back, which is computational in nature, like a function, right? Well, it's computation biased, but you can still describe data with it. Church numbers, is that how they call it? Church numerals, I think, maybe. And any data structure actually, so there's this duality between a function and a data structure. But so that's at the very kind of foundational level, mathematical level, or computer science level. But I think it continues to surface in sort of these extensible data structures and these approaches to solve the expression problem, because they're very connected actually to this. So in such a way that in any case, and that's probably also a byproduct of the declarative bias of functional programming, is that you're kind of declaring what your programming language is like, and then that's and declaring it is part of declaring what a lambda is going to do, what a binding looks like, and what applying lambda to a term looks like, what a type, and then for a type, like simply type length calculus, how you store the type in it. So everything gets reified in order to then be run. That's really the essence of programming. So anyway, that's a long-winded way to say, well, yeah, if I have a distributed data language, I forgot to say, a distributed algebraic, which is another nickname for this kind of composability that we want, and this kind of expression problem focused approach. Algebraic means you have ways to combine things, and you know well how things are going to behave in the small when they're decomposed, and then when you compose them. So so if you have an algebraic data language, you're really a step, just a small step away from being able to use that to describe computational structure. You just need to say, well, okay, I'll use my algebraic data language to say that this type of thing is going to be a variable, and this type of thing is going to be a lambda, and then off you go. You now have a way to describe your programs in this even-based distributed generic algebraic data language. soup of buzzwords that end up not meaning much. So yeah, performance projection, and then I guess you're gonna stretch. It's not a stretch goal. It's a way to say, I think, stay connected or hanging to lambdas, I would say, compilers maybe, or PL, programming language science. Okay. All right. I'll go to the drawing board. Oh, I need to transition and I need to get out of studio mode. All right. So as you see, it doesn't make a lot of importance if I have the camera activated, but I suppose you can see me leave to the drawing. So maybe that's scenography or whatever. Okay. So I started by basically my idea from this morning is, hey, I talked about generics SOP, right? And generics SOP as, well, in fact, a data description language or an algebraic data type description language, a ADL, if you'd like. And I thought, hey, if maybe you could reify, well, in fact, what are data, that's a DDL, that's a ADDL. That's a way to say, maybe I can describe an operation, which is plus S, that says I'm going to add a constructor to my sum type. And so here I'm using prior thinking which comes from this idea, and I've shuffled things a bit around, but it comes from the idea of something you see in Datomic, actually. They call it EADT. In the semantic web community, it's more like SPOG. But the concepts are pretty much mapped one-to-one, except the EADT stuff from Datomic is specialized, you would say. And so is SPOG as well, because it's kind of linked to RDF. But EADT means entity, attribute, data, and transaction. And SPOG means subject, predicate, object, graph. And so this is SPO is usually affectionately called a triple, and RDF stores are usually affectionately called a triple store, and a triple store is the workhorse data store for the semantic web, or linked data, as it's called. And when you add the G, then it's called a quad. And a quad, and so you have quad stores as well. And the G is for graph, because that's how, but it doesn't mean a graph database or anything like that. It's just a concept. It's something that I prefer to refer to as context. And so I decide here to make the first thing before the comma a context. And then I changed what my schema is like as I went along, and so it's not exactly right. But then I want actually the second thing to be predicate, and then I want I think I want the subject and then the object, but because predicates are usually they're not symmetric usually. If I say I'm in the house, you can't say that the house is in me. It's not symmetric. It doesn't work. So I decide somehow arbitrarily, and it probably is not always clear, and it's not formally. That doesn't really mean anything formally, but that my subject is bigger than my object. So it feels like in this case, I have my context is really the bigger thing. And then the predicate is, I would say, it's what gives meaning. It's kind of the arrow in some sense. C is kind of a category as well, and P is kind of maybe the arrow, and then S and O are objects, and S is kind of the bigger object for whatever reason. Because I want to. I don't want to have to make some choices. Basically, I want some things to be by convention in some sense. But except that that's all well and good. But here I kind of reverse things because I decided on this order later, and everything is subject to change here. You don't know that already. So op really is the predicate that I'm looking at here. So meaning I'm actually declaring an op, and so probably in fact it might be that I'm just declaring something, and I kind of like this idea of a column equal as a declaration that exists in some other computer science context, like a BNF, I think, or whatnot. And so that's my predicate, and then my subject is the plus S. So I'm going to define what plus S is, and I'm doing this in the context of this SOP domain. So here I'm deciding that my context is kind of an SOP domain. Whereas here, the line before, I'm kind of saying at the root domain, I'm defining something even more fundamental. I'm defining what an op is, which might be, in fact, defining what definition is. So it could be that you have a kind of a circular grounding, kind of tying the knot kind of thing at the top. But I'm getting super abstract here. But so, and then you define plus S as some kind of operation that is of arity 2, for instance, and that would have a certain domain and a certain range. So here I'm mixing things from, category theory and hypercategories, actually, because arity is in a regular category, you only have arrows that have one object at the source and one object as a target, the domain and the range. But in hypercategories, you can link an arbitrary number of objects, and I don't know how that's actually called, but also you might want to specify whether your arrow has some sense of directionality or not, which might completely depend on whether, for instance, you're in a relational category, then your directions don't matter, or you're in a more functional category, and in that case, directions matter. You want to know that things go from A to B, because that implies certain characteristic for how your objects are laid out. So what I'm hinting at here is that I want to be able to hang my definitions in something more formally clear. And clearly that needs to be some kind of category theory, because that's the universal language that I think can best describe any of the other languages that we might want to choose. Because the moment where you want to specify what operations are sort of allowed or not allowed, and then if you wanted to span things from describing data, maybe describing logical propositions, or describing programming languages, then you need to be grounded in something fairly abstract and able to be applied to a lot of these languages, to a lot of these domains. And the best thing for that is category theory. And there's some fun things about equality and homotopy type theory and higher dimensional category theories. And so that stuff is super nice. And I think we can probably I'd want to be able to hang from there without having to solve the problem of how I'm hanging before I go lower. And the reason why I say hanging is because in my worldview, these deeper mathematical insights hang from our minds. But usually the goal of programming is to have some objects like audio streaming that are grounded in reality. And so meaning they sort of symbolic representation for something that might exist in the real world. And to me, that should be called grounded. Whereas usually you would say maybe that a mathematical formula might be grounded in some kind of logic, but for me, it's hanging. It means that, I have things hanging and things grounded. So I'm connected at both ends, hopefully. Right. So if we have this kind of algebraic data definition language, which is really more than that, it's the migration language for that. So usually a DDL doesn't necessarily have that, right? So it's the dynamic version of that. It's the language of how I change my DDL. So in SQL, for instance, a DDL would be a create table, right? But it could be also add this field. Also, I guess, DDL contains the migration language. At least a schema migration language. It might not contain a data migration language, which are different things, right? So if you do a schema migration, as I was saying earlier, this might imply a data migration. Okay. So what do I want to be? If we choose SOP as the kind of abstract framework for data definition, algebraic data definition, then what does migration look like? Schema migration for a start. Well, it looks like something like I would add a sum to some existing type, I guess. And so the domain is any domain. I said root. It might be not. It might be star. I don't know. And the range is some kind of sum, because we want to add a sum. And so maybe this means we add a sum, and I think this is what I came to a little bit later, is I think we're adding a sum constructor to some existing sum, or to the empty sum. So we might want to be describing, so in our case, we might be saying, okay, I'm adding audio so this will be plus S. I'm adding audio to sources, and actually, in my new, it would be plus S. Actually, I kind of like column pipe, because pipe is usually used for some constructors, and so for product we can use plus and. So column, or sorry, not plus, column. Oh yeah, well, maybe I say plus. It might be plus actually, if we want to add something to it. Oh yeah, I don't know. The notation is floating. And also, I'm not sure whether this is actually any correct. It might totally not be, but I want something that I can somewhat read, because it's grounded in some principles. Okay, so let's say plus sum. So the bigger thing is the sources, and to sources I add an audio constructor. So because of my definition, I know that plus pipe is something of arity 2 that takes any domain, and so that's my domain, and as a range takes a sum, and that really we mean, I think, a sum constructor. And my sum constructor, here I decided it's going to be audio, and it might have some extra parameters in the way that it does. I thought my screen was frozen. In the way that we saw was done in yesterday's code. Was it this code? Yes, it was. Let me put it back on screen. Here, when we did these EADTs, we added these constructors right here. And even though these are members of an open sum type, right, an extensible sum type, they have a payload. They carry name and source, and E is just to allow the extensibility stuff to kick in. So so they carry some data, and this could be yeah, here they're generic, but it could be specialized. So we could say no, we can only have strings in the name position, for instance, right? And what does that mean? It means audio here is the constructor name, and then I have the name and the input. And I define that the type of name is string. Yeah, and I was playing with this idea of saying, well, maybe type of name is like some kind of maybe optional string. I don't know if that would work. And then the input would be maybe some URL. I think we can, or URI, or maybe there's going to be a different name for how we locate things here. But the idea is to take a page from the Semantic Webs book and also various content addressable strategies like IPFS and whatnot to sort of have to use URLs in a way that's kind of meaningful in the sense that they can help create unique identification for certain things. Or at least, yeah, unique names with as much unique as we can make them depending on their semantics and whatnot. And so that's another idea, by the way, that I haven't really talked about and that I haven't really, I've mentioned here, is that maybe, we want to describe operations for a domain. So we say, well, and here I sort of say, well, the SOP domain is part of the root domain somehow, like this, is included in the root domain. So it wouldn't be written like this. It would be written, actually, should I start writing this down into maybe a new log? New file, log, and that would be, well, schema. Okay. And I need to go to my coding screen. Right, so schema, what am I saying? I'm saying something like top level is context, predicate, subject, object. And such that the predicate points from bigger to smaller, whatever that means. It might not be always applicable. And so I say that there's some root context in which I define definition itself as something that has arity to maybe just arity to as domain, maybe anything. Can define anything to be, I suppose, anything, right? I know, I think in my paper, I imagine that maybe there would be something that's like a magic type, like a internal primitive, or like a prim in Haskell or whatever, something underlying that's like a definition, because at some level that's a way to sort of bypass the fact that I can't define all of the stuff that I'm hanging from. So at one point I might just say that there's some magic thing that's a definition, and that's going to allow to, and that this itself is a definition, right? and that that will allow me to then later refine it and make it more formally. I was going to say grounded, but hanging into some proper math. But def could be, let's say, for now, like any math, basically. Okay. So maybe that's part of a magic thing. Def hang from any math. And in particular, I think we'll want to start, yeah, then maybe there's something more defined than a def that's executable somehow, or at least, yeah, I think, I think executable is a nice way to put it. It implies that it's parsable, but I think if we put laws in there, then we want it to be executable somehow. So very broad setting, and I think maybe in writing, I'm not going to put the spaces, the commas, and that's it. Okay. And then what do I have? Oh, I'm not in the right screen. I might go in that mosaic screen for a bit because I've been, but this is maybe too small, right? Yeah, I think I should do a screen with both coding and drawing, but that would distract me from this very interesting thing I'm doing right now, and I don't want to be distracted yet. So we're saying something like that that the domain SOP, yeah, there's something else that I haven't, like primitives maybe, and example. Yeah, it's this idea of, maybe it goes there. Like the context includes a protocol, or can include a protocol, or it maybe implies a protocol, which in turn implies data semantics and maybe even computational semantics. Oh, by the way, I talked about unison before, but I need to be given another prop to a slightly controversial other part of the domain space here, which is OR and orbit. I think that all of this stack is also very grounded in this idea of distributed everything, kind of a ground up revision of what a program is and what computational substrate relation to programs is like. And I think drawing from a lot of the functional programming lessons and maybe even more than that. I've only passed the surface of that, but I thought I'd mention it. Let's see, what else? Right, the reason why I say that it implies a protocol is because, for instance, we might want to say that root has maybe open world semantics, for instance, and it might be public and sort of integrity checked. And it might be eventually, might be strongly eventually consistent, for instance. And it might be also verified, formally verified. So that, you know, in practice, anyone could add something to root with some that implies governance as well. another thought from this morning. That if you add something to root, then it needs to be, because everyone's going to sort of get it, because it's public. You want some governance because it's like DNS, like you need some ways to deal with conflicts, transferring things, kind of administrative. And you want it to be integrity checked. You want to make sure that decisions are traceable. And you want it strongly eventually consistent. So it's okay if you're a bit delayed, but let's say if there's a new domain that appears and you're like, for instance, you get the program that depends on the new domain before you get the new domain, then you probably have to wait until you receive the new domain in order to be able to compute something like that. So strongly eventually consistent, but also I think there's another word for this. You'll kind of wait indefinitely until you have your dependency. You won't go cowboy and try things even if you don't have the dependency. So there's something about mandatory dependency instantiation. Whatever. Hey, I'm inventing words. It's all good. Just means that you need dependencies to exist before you do anything, and the runtime should kind of guarantee that. And anything that's put in there should be formally verified. Yeah. Okay. And then it means, what it means is that the context of, for instance, if I have a user-defined context like my user-defined context, then I get to decide what the semantics are. Whatever semantics I declare. And so that matters to me in the sense of, for various reasons. One is privacy and security. Meaning my context might involve whatever, double ratchet encryption or something, like a strong peer-to-peer end-to-end encrypted with like device verification, off-band, whatever. Like the specifics of the protocol might be where I have require high guarantees in terms of how things are operated. So that's one dimension. Another dimension is just like the transport dimension, meaning I want to be also able to know what I have available as ways to propagate stuff. And then something I guess that are like the distributed, well, the convergence semantics, I think might be a good way to call them. Yeah, and you could say like this mandatory dependency instantiation invention there. Now that's kind of a convergence semantic. It's to say, well, in order to move forward, you absolutely need to have a parent. You cannot not have a parent. We're not going to process and compute anything until the parent shows up, so that the parent then contains some of whatever guarantees or type definition and semantic declaration that would allow whatever is downstream of it to be trustworthy. That's another, I guess, layer here. So not convergent, semantic convergence, semantics. So, you know, eventually consistent, or, you know, something, I guess you could have transactional, like in the old school kind of way. And yeah, you could have more specific things like, is it an or set, right? Some things like that. And it doesn't matter what the implementation is if the implementation can be either formally shown to respect the semantics, or fuzzed and tested in the wild, like constantly, to show that it actually respects the semantics. Yeah, and then I suppose you could have like computational guarantees of some sorts, like, as well. That's probably a subset of data convergence guarantees, but indeed, like formal verification. Or like black box, some form of black box contract of sorts. That's testable. Okay. So SOP, when we're at that level, we're kind of still quite a bit in the root level. We're in the meta model level. We're saying we're kind of providing the, you know, the standard library for using this stuff, hoping that it's, whenever, you know, it comes out, it's properly hanging solidly to good math. And what else? Then I might say something like, so maybe in the SOP domain, I define that, I decide the AV domain. I don't know if that's right. No, that's not right. No, I think in the root domain, so I want to say that I create a domain called AV, and it's probably kind of like in the user space. So here we're not in the kind of core or kernel space anymore. I suppose we could say, yeah, this is like kind of the core domain. This is user space. And this is kind of core space or root space. And so I want to say that user AV implements the semantic of SOP. And so I don't think that that's the right way to say it. So there should be, maybe it's to say it's of type SOP, using what Haskell uses to say type. And since we do the more generic thing and the smaller thing, what this means is user AV is of type SOP. Yeah, I kind of like that. What else do we have in our drawing? So yeah, that's a better way. That's a better way of doing this, and that's a better way of doing this. Right, and so then I want to kind of try and define whatever this adding a sum or adding a product feels like. So let's do a bit of that, and that's going to be in the kind of SOP space or domain. And my operation is definition. Oh, I moved the screen. I'm sorry about that. The microphone is really good, but you can hear that. Right, so we make a definition. We say that plus type is of arity2, has domain anything, which usually means any object. And we kind of, maybe we're in the category of kind of Haskell, a bit kind of in Haskell, maybe a bigger thing than Haskell. And the range is, well, the range is, so that's an interesting thing, right? Like the range, I was going to say, is like some kind of constructor, right? Like the sum constructor. It feels like I don't want to use snake case here. So just say a sum, and we don't know yet what that's going to be like. And we define also removing a constructor, and removing a constructor, something that takes, I suppose, yeah, anything. Again, it's really a type, but we call it star, and the range of it is going to be that constructor. And then we do the product version of it by saying and also has arity2, takes the domain star, and has range a product. And same thing for removing some product from a thing. So I suppose then the question is, what is a sum and what is a product? And maybe this is an SOP sum, and maybe this is an SOP product. And we say, well, in SOP, we define a sum, and here we kind of have some pattern. Well, it's something with an arity, I suppose. It's kind of an arity star, in fact, because we want to do, because I don't want to use, I think restricting to quads, in practice, we might be serializing things from the fourth constructor sort of together, just as a kind of a, maybe wire or the wire optimization, or even maybe persistence optimization for the log, because this is going to be an event log, really. But I think we want to be allowed to do anything we want in the last part of the quad, which is the kind of the object part of the quad, right? So that we have complex things in there if we want. And here, by saying arity star, we mean, yeah, any arity, but any arity, but with some regularity, right? So, and the regularity is that it has a constructor name. And so what is that? It's a name, which is, well, it's going to be a symbol. And then it has any number of what? Any number of constructees. They're fields, I suppose, which are also symbols. Do we say something like this to say that that name has a cardinality of 1, which is implied here, but this has the infinite cardinality? Maybe it's not bad. And then the product is actually the same thing. Which is nice and regular, but they mean different things. And the meaning, that's that I've started drawing this a bit, right? Say plus laws, and only sums at the top, for instance. Well, that's a weak law, but there's more laws that come from this definition, and ideally you want them expressed in some kind of executable, parsable executable definition of some sort. So how would you declare that? You'd say what? You say SOP has some laws, some executable law for sums and products. Something like that. And maybe if it's executable, we put it in brackets, or we put it in backticks. Probably backticks, huh? Maybe we even put a bang on in front of it. Okay. Go back to the drawing. What else do I have? Right, so here I was trying to define definition itself, which we've done. Trying to define operation, but I think that's actually subsumed. Yeah, there was this thought in my mind of what is an object, what is an arrow? Can we define this? And is that the same as sort of verification? But maybe that's a hanging question, and I don't want to get into that yet. Yeah, I think it's best to not go into that. And right, then finally we get down to an example of being in the AV domain and what it's like to add some sources. And so now we're down to, and I go to the coding page, we're down to actually using this stuff. And so we say that the user AV, it's the user space, but this is what the programmer will write at this point. And so what do they write? They write that, yeah, in the root domain, they kind of hang that thing to the global space. They say, I have an application, it's AV. And then I suppose we just jump into the context of the application. And we want to say something like that we are going to be, well, making a definition, I think. And we're going to say that sources, or we're right away, we're adding sources as something, we're defining the audio type, saying, yeah, audio has name, that's a string, and an input that's some other type. Yeah, so probably it should be some kind of, it should probably be a way to differentiate types. No, maybe not actually. I think maybe not. So name would be of type string and input will be of type user AV input. And in the user AV domain, I could say that user AV input is actually a product. That's input. Maybe we want to do some magic like this, but I think we could maybe safely say that this implies that it defines user AV sources. Which, by the way, is kind of like an aggregate event sourcing. But yeah, this doesn't necessarily mean that that's a context, right? It means that it's there is some handle. And maybe that's part of the very high level definition of the structure of this is that all of these are handles, which is similar to the RDF model. I forget how you call this, maybe axioms. No, it's even more than that in programming like this. Forget, doesn't matter. I see the shape in my mind. Okay. So maybe this creates the user AV sources handle automatically. And maybe I don't need to preface this by user AV input here. And this is so maybe we want to define types, like a definition for type is of arity 2 and has as domain some term. Oh, so that's interesting. Because it gets into dependent types here. I want to say something like n like star -1 and range star, something like that. Star star. I don't know what this is, but I want to say that whatever is on the left of by the way, this is now in the definitions space, which is not the same as the predicate space. So when I'm here, I'm defining both, and that then this has similar semantics, but maybe infix. In fact, yeah, it doesn't go in the correct direction anymore now. Subclassing, I think. And I want this to be typing. Okay. And here I'm saying, yeah, that this is the root string. It's from the standard library. And it might be defined somewhere as string is like some executable thing, like someplace in memory, or like some serializable thing. Like like a protobuf, a CBOR. We are going to, let's see. Like this, something like that. Or prem Right, because this is a name. I've been seeing these as field names, but maybe I should, put them in curly brackets or something. It's kind of what I imply, right? That anything past the fourth is actually objects. So, right? So it's context, predicate, subject, objects. It really means, well, field or basically key value. I think field maybe, I think that's better. Field type, actually, yeah. And field type. Ah, right, so in that case, yeah, but then do we want to also allow this, in which case it's field equal value, right? And what's the difference? In one case, we're in the schema level, and the other case, we're in the data level. Do we even want to use different notations for that? Is that going to be implied by the context? I don't know. It would be implied by the predicates, actually, wouldn't it? In which case we could use always the same notation, except that, yeah, it might be confusing, but I think if we use some, like if we say actually that this is colon pipe plus, then maybe it means, yeah, it's a type level thing. So here we have a field and here we have a type. And so fields are symbols, but types are handles. Is where I wanted to get to. Typing rules. So yeah, maybe we just do equal and we say, well, this is symbol and this is handle. And that's basically the same as, oops, something like this, right? Whatever that means. A way to make the object be a richer structure. Because in RDF, if you're stuck with quads or or with triples, then this kind of stuff is actually pretty hairy to do. And one of the reasons why usually people go for things like Neo4j, where it's more like this. It's more like a document structure. But you obviously need to be careful about semantics there, but I think if the predicate immediately implies how you interpret this, then it's okay. So here we're saying this is a type level thing. So let's see. Now we specialize this by saying if we have a typing predicate, some subject, then it means field and type, field and type. Whereas if you have a value predicate, it's sort of key value, really. Key equals value. Which I suppose you could say field. Probably key is better. It's nice and short. And then the difference between a key and a handle. That there are different places on the door. That's funny. Door metaphors. I like that. Okay, so keys it is. Nice and short. See. And so these are keys. Yeah. Okay. All right. So the equivalent now for adding a product constructor and removing a product constructor will be like so. And so we define input with a constructor. Well, how do we define? Well, actually audio has audio input as a constructor. It's not any input. It's actually audio input. Probably dash is nice. And audio input. And what's an audio input then? Well, you can have the constructor audio input. That's fine. How was it in our code? And audio input had the audio input constructor. Yeah, it's really fine, right? It's fine except if they're in the same space, then that's not fine anymore. Then we might want to say types. Ah, that's ugly. I want this. Types. Since I want things to be sort of be able to hang from any arbitrary height and to allow other things to hang below, meaning I don't necessarily want to lock down a term level, because it should be possible to extend the term and say, well, actually, that's just a type now, and here's instances for it, which is something I haven't seen much in the literature, but I'm not an academic, so I don't know. But I kind of want that for some reason. I don't know. It flatters my symmetric sense. The fact that things could be, that you can have an infinite tower of type going up, all good, but why not going down? Why is it grounded to terms? Clearly, terms also change shape in such a way that you could, whatever you were, especially because you're refining your understanding, you thought that this symbol was grounded, or this data, even this data point, was grounded in this thing. But then, you need, actually, it's more complex than that. There's several facets. And so, in fact, I need to somehow attach new information to that existing handle. And so that is a kind of a data refinement logic where you could transform an existing data type that's not refined enough to and graduate a data point to a data type under which there are more refined points, something like that. And yes, okay, so audio input types, I say. So yeah, because then in that case, I don't want to necessarily ground a symbol for types or not types. Like in Haskell, usually, well, yeah, types have a capital first letter, for instance, right? And so that's an easy distinction from them. But if we have this kind of lack of distinction of what a term is, then we can't really reuse that. So how do we specify a type? Well, it needs to be, I think, locally meaningful. So in that spirit, then maybe this is an audio source input because it's in the context of defining sources. And so we say that an audio source input means you have an audio output input constructor that will have a name, which is going to be a string. And that will have then it will have, let's say, a dev. That's going to be maybe some kind of like sysdev or whatever. I like this. Okay, so that's the programmer. And then the data, which I suppose is our grounding at this point, it's going to be something like user AV sources, or we're going to maybe create an audio input, create. So where do we create it? In some context. Where is it? Maybe it's in user AV, but it's mine. So it's in the June one. Maybe we put an at. So in my user AV data space, I have an audio input, and so that needs a name, right? So hold on. What am I doing? I'm adding it. So I'm just adding it. I think that's how I was when I was thinking about this level of things. I was thinking just plus here. Just add a source and you're good. Yeah, I think that makes sense. Then this plus is has some allows to have some space for typing, right? You say plus, and then this is a type, and Oh, well, that's supposed to be the constructor name. We could, maybe we don't need to add these things. 1, 2, 3, 4. Yeah, maybe this is just redundant here, because the domain is just the type, and then the range is the product, and the product is just some name key fields. Yeah, I like that. And so what the name is, well, it's right, my video card HDMI, like, yeah, HDMI input 1 or something in 1, and the device is going to be something like dev audio 0, yeah, like N0 I1 or something, and then maybe I add or whatever the order really, I add a source as well, or yeah, just a source. A source is going to be, huh. Yeah, I see. I'm looking at the regularity here, the fact that I didn't need a constructor here. I think that's maybe inherent in the fact that we define a product type, and so the constructor are what's all defined here. Whereas with a sum type, we're going to have video sources, and they will have a different input, and a video input is going to still be very similar to that. Oh, maybe it's going to be some kind of video star, some kind of audio star. That's interesting. Quite like that, actually. So then a source, what is it like when I add a source? Well, what do I add it to is one question. Here, that's also a question. What do I add this audio input to? I might be defining, even we're not in the type world here, so I might be saying base input is no, so I give the type and I say yeah, I suppose it's related to the name thing. Interesting, because this is the name of the constructor right there. Okay, let's see it play out fully. So here, what am I saying? I'm saying audio input. No, I'm saying a base input is of type audio input. So really, I'm giving a type. It's kind of a declaration. That's probably fine. And so can I do like my sources and say that it's a sources, source. base source will be, what I want to write here is just, I mean, I can give it a name. Might not be the same thing as, might be a user readable name here, right? And here we might make it, yeah, a user readable name. And then the input will be user AV germ audio base input. I think that's fine. So we're sort of saying that, yeah, that for any term level predicate, we always include types, which I think makes sense. That's how you get to do type verification or type inference, type checking or type inference. Okay, and then my final example, and I'm going to also drink. Actually, let me take a little bio break. I'll be right back. All right, I'm back. And I've ordered some food as well, so I'll go probably for another 30 minutes or so, and then I will eat. Okay. I like how this looks. Right, so I think then I was trying to play with this idea of a route, because that's what we were doing before. And so a route, right, so can we define a route in the programmer space as something with arity 2? So it kind of implies route is a predicate if we say arity 2. Which is something that I think is connected to this idea I had before about declaring what are arrows as opposed to what are objects. And yeah, I think something like for now implicitly I'm saying arity equals da 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 means you're defining a predicate. It's kind of a ad hoc, I suppose, ad hoc. Don't want to think about something more regular. I think there is definitely a way, but probably a way that also works with higher category theory, where arrows are objects in the higher category or something. Okay, route. Okay, I define a route as something with arity 2. Yeah. And such that the domain is sources, and the range is or domain is a source, and the range is a sink. So that's wrong, actually, right? Because it is sources. So domain is, oh, well, no, actually, a route. Oh, yeah, a route is something from a source to async. Maybe that's acceptable, but maybe it depends on the domain. I'm thinking, because if that's the case, then, well, first of all, we'd have to kind of define sinks, and we can do this because it should be pretty much exactly this, except it should have outputs, right? And then you can say that's some device will have outputs, and yeah, I guess we can do it for video. Doesn't bring much to the example, but we might want to make this executable or parsable at some point. Okay. So, right. So a route will go from a domain, a range to a sink. So that's where we have stuff that's, I don't know how to define it. So, okay, let's say I define the backing track. And that's a file. That's in users journ, home journ. extract.mp3 or something. And right, then we have well, we have another source. Then I was wondering a bit about whether source is redundant with an input. In this case, it feels a bit like a source is a kind of a handle for an input. That you could say, well, my base and the way it's routed downstream now is connected to that input instead. So you can just sort of patch your source to a different input, even though, and then downstream your source is patched to some sinks. But the real patch bay is in the between sources and sinks. That one is more like a graph, whereas I suppose the other one, upstream and downstream, is just a simple, like just a switching patch of sorts. So that's the backing track, source, and yeah, backing track, again, not the best. I suppose, yeah, no, I suppose that this would be, you know, this would be like, okay, what's a, oh yeah, it would be it gets funkier. So that would be a specific track, right? But then the source would be the backing track, and then just happens that so if it's a switching relationship, then maybe it's not class here, maybe it's equal. And that defines some semantics. Let's see. That's connected to Dina, I think, the language. This is this Dina language, which has this notion of defining data types like, yeah, the plus equal and the change, and like you have an underlying understanding that what is it, plus as right, that plus equal has additive semantics, whereas a column equal has atomic semantics, I think is a way to say it, right? So equal, or we define equal as well, something with atomic semantics, and then plus something with additive, like maybe monoidal is the right way to think of this, maybe. Yeah, because, and so I'll want my source to have atomic semantics, but I want my routes to have additive semantics. So how do I even specify that? equal plus. Why not? Then we say user AV June. And by the way, I haven't talked about this. I talked a little bit about this in the protocol thing, but this will include whatever definition I need to have about how it's going to go over the wire. Yeah. So I'll be able to add routes, or let's say, and so this will kind of be like the scene, like calling it a route might be right, but if we feel like here, I'm kind of referring back to my earlier thoughts about the fact that these might be static routes in our matrix, but we might have these kind of dynamic scenes. And so ideally, I want those to kind of maybe have some kind of subclassing relationship. Maybe routes will actually turn out to be scenes later, but maybe it's okay to think of them as routes first and take it from here. Let's go back here. And so how do I say that sources have an atomic semantic? I go here and I say semantic equals maybe this is the proper, maybe there's no point to say equal. Maybe this is just exactly the same thing. I think it is. Yeah. And then it fits Dina, which I like. Okay. So, okay, in the playbase routing, okay, let's call this a scene. Scene will connect some sources and some sinks. And honestly, it might also connect some, right, what do we want to say that it might connect if it's dynamic? Okay, I suppose I am actually trying to think about the broader problem because this matters. So a scene, something that potentially is time indexed, it contains routing. The only real difference is that I suppose there's a notion that scenes are in a atomic, is an atomic thing, that there's only one scene that's active at any given time. Aha. All right. Interesting. So maybe we are saying that routes are additive, but that scenes are atomic. And then what's a scene? Is it just a route? And yeah, I suppose it's a name, which is a string, and it's a route, which is a route, and it has atomic semantics. So then we can say we have some routes like, well, we're going to add some routes, but interesting. The playbase scene. Yeah, I think I'm a little confused here. Route. So Right. All right, we'll go from a source to, so we'll connect base source to, and then we'll have some sinks. Right, and so in my this example, things are video. So those are really the monitor sync, the stream sync, and like a recording sync, for instance. Those are three good examples. So if we have the monitor, or like, let's call it preview. I don't like preview, monitor. Maybe control, actually. Yeah. Or remote. Control is good. And yeah, that's has a name. Yeah, it might just be headphones, for instance. And now really, I'm kind of thinking, I'm kind of thinking headphones plus stuff. Yeah, well, that's great, because actually one of it might be an audio output here. So the output will be, well, I need to define the audio output. And the audio output will have headphones, and the name would be headphones, and device will be dev/audio something, or L2 or whatever. And then I will have maybe some kind of video output, which will be maybe, oh, well, that I suppose could be called preview. And there will be some screen. Screens are also on videos usually, right? And yeah, so I have to duplicate things again, but I suppose these things are static, whereas these things, yeah, they swap between, they can swap. Output is audio. It's headphones, that's the name. And output is his preview. Possibly collision here. So I suppose that's monitor. The device is kind of a monitor. Oh, didn't I call these devices in the end in my code? Input. No, but I did. Oh no, it looks like I didn't in the end. Okay. Okay. View output monitor. Yeah, control and preview. Doesn't really make a lot of sense. Yeah, but fine. And then yes, as I said, we have other syncs, because we have, well, we have multiplexed outputs. Yeah, I didn't think of that. We might want to consider devices as both audio and with both syncs as both with audio and video capabilities, right? So that's a good example of then of doing a migration, in fact. where we'll say something like, yeah, now our syncs are they can also be AV syncs, and they have a name with a string, and then they have an audio output with an audio output and a video output. Oh, okay, let's say audio and video output. And once applications receive this bit of information set by the programmer, then they can start using it to use multiplexing. That's how I'm viewing things. Video output, and so stream, and it's going to be like Twitch or something, and device is going to be RTMP something, blah. And here we'll have a record, and there will be yeah, we don't have the video outputs here, but yeah, it's all good. Call this recording, and maybe some file user home. Probably be tilde, to be honest. Recording.mp4, for instance. And I sensed my phone going to ring anytime. And right, so another sync, yeah, that's not going to be headphone, that's going to be monitor. And then some other syncs are going to be stream. Oh, maybe that's going to be called Twitch, actually. It's Twitch output. And that's record. Maybe it's recordings. Maybe it's a folder. Maybe we call it archive or something. It's a recording. And we have stream. And it goes to Twitch. Whereas you also record to archive. Basically, these things don't, I think the inputs having names might be overkill. To have both the well, in reality, it's a user experience thing, and they would probably have names. Okay, are we ready to route finally? We can route the base source. Well, we don't have an audio output. But let's say we do this in the post-migration world, and therefore we have access to the new multiplexed syncs. So then what do? We just replace the stream sync. Maybe this should be ID. No, this handle is the ID. We replace it with audio, Twitch, audio, and video. Well, to be honest, is my foot. All right, and I'm back for just a few minutes, just trying to finish this thoughts of how we would then route to Twitch video or create this sync. And so in fact, a base source route will patch the audio input the base input because, oh no, sorry, route takes a source and then goes to a, well, Twitch audio, I suppose. That would be a route, right? And then the backing track source will also be routed to Twitch audio. And I could also say, well, the base source, that's going to go to the control, like monitor. I think I called it control, but let's call it control audio to make it clearer what's up. Audio. And maybe control video. Right, so but we're dealing here with audio routing. So we see here, we'll be able to say both. So it has a kind of a relational additive semantics to it. Like we're kind of saying, well, between any 2 points, you can have things that in the kind of traditional set description of what a function is when you're trying to understand injection, bit by injection, and whatnot. Here we're kind of saying, well, we have two sets, a set of inputs, a set of outputs, or a set of sources, a set of sinks, and we just add any two line between any two sources and sinks, or target and destinations of those lines or arrows. So yeah, that sounds fine to me. And then I think we have a set, like the difference is, yeah, do we have a set or do we have a map of sorts? Can we if I do this again, is it idempotent? So there's lots of little details to figure out, which in my view are addressed by saying, well, you define precisely the semantics of, say, plus, and then if you want a slightly different plus, then you define the semantics of that and you use that. Of course, choosing what is the standard library plus is a difficult topic, but I think with this approach, everything could be pretty much overridable. So it would be all good. Okay, so routing satisfies me, but then scene, how about that? So scene is a kind of a handle on a particular route, but we don't have a handle for routes. We need to add that, which is fine. But then there would need to be arity3, I suppose, and have a name, right? So that's interesting. This might imply a kind of a transaction number. So you might have a kind of a machine ID for this statement. somewhere. Could you reuse that somehow? Can I kind of do like bashism like this, right? I mean this route. And I suppose it's possible, right? Because if it's a set, then you know which route we mean. So we can, yeah, actually, yes. I think I thought of this before. What it means is that it tells, and actually I can show that I have thought about this before in my drawing. It's the sort of, right. I thought about it as saying, we might want to say that we define a subdomain handle for some particular object. Basically, the idea is, can we sort of automatically construct unique IDs based on some stuff? Or do we want to actually declaratively say, well, actually, let me attach this to this? And so it might be different in different cases. I suppose here I kind of like the idea that maybe it implies a handle that's like user AV adjourn route base source tutorial. And then I can just reuse that in my route. Oop. And even say route equal, right? Except that that's a single route. So it's a bit heavy to, that's not really a scene, right? So I think that's where our scenes is not exactly, I think our scene are many routes. And so maybe we define them like so. Like saying, well, the playbus scene is also a control audio route. And in this case, I definitely want to have, or maybe I want to have automatically implied handles. But that might be, again, something that we allow to be declared at the domain level. And we say in AV, we automatically create those routes, but maybe in other domains, we have to create them manually. Like in root, for instance, maybe disabled. You can't create things automatically. You you can declare something like that. I'm going to make a note of that. Implied handles. Oopsie. Dot out. Might be forbidden in some domain, like root, enabled with specific default route, default patterns that are user defined. Like exactly this, for instance, right? Or we might have a default too, right? Might be enabled with defaults like this, or with custom patterns. Okay, I like that. And then, well, I don't know about this notation for a set. It might be, a space, but easier to see. Might want to interpret a new line as white space and be happy with it, maybe. We might want to use a dot at the end, like to help with parsing, like RDF does, or at least So the like and turtle and which one do I like? Trig. Yeah. Okay. And then I can replace the play base scene with a new set of routes. Which all works fine for me. Of course, I could also make scenes be defined by plus and then add routes to a scene. Maybe that's the better way, actually. And then the main difference is that we have a handle, whereas for routes we don't. So we go back to arity 2 here, and we say handle default. And for scene, well, no, it is arity 2, except that it's not a domain and a range, it's a name and a route. So there needs to be something else here, I think, that defines whether there's a handle or not. And so here maybe we say implicit. So we don't have to define a name. So when we define a route, we say do we really say plus? We don't say plus. We say route. Then we don't need the handle. We know the semantics are plus. Ah, yeah, semantics are plus, but we might want to remove a route. That's the thing. So maybe it's just that it's plus route then. And we implicitly have a plus route and a minus route if we have plus semantics. In fact, plus semantics might not be the same as plus minus semantics. And here we're defining the type of route. So it is equivalent to saying operation type. I suppose maybe we need to be explicit about the fact that we do pass a type here. The handle. Maybe we just say we pass the type. In this handle implicit thing to be defined somehow like this, I think. Oh, well, actually, this is an example of this is a type of one level higher than whatever this handle is, whatever that means, which is to say it's a type. Maybe. And so the arity doesn't include whether we specify a type or we specify a name. And so this thing arguably maybe go here. And probably we say just 3. So the pattern of this, the range being a def, kind of means that def is of the shape handle, actually handle pattern, arity, and then key values. Something like that. You find it also up there, but yeah, with less detail. And then what a handle pattern. Well, I want to kind of use the SOP thing here, saying that plus I want to say handle patterns have star, and then this is any type, and then any handle, star star, any handle handles which subsume another handle in the def, something like that. When we define something, yeah, this is the handle we use to define the thing. And we're kind of saying that the semantics are atomic. Like we can't redefine the same domain several times. But calling it domain, is that right? I think so. Okay, I tend to hover in the hanging gardens. But yeah, back down into on the ground. Then what was I saying? That there's a question about scene and whether this should be a plus. And that somehow it depended quite a bit on the fact whether this, oh yeah, there's the underscore. So the underscore handle pattern means like it's like a blank node, no handle, except implied one. So is this just a sort of syntactic thing? It's just we say, well, yeah, if you have this, then we imply your handle. So like route that has an implied handle, just as a convenience. We could give it a name, but we want to avoid giving it a name, so we put an underscore in there, and you just refer to the route. And I think that makes sense to me. Whereas the scene, you say, well, the scene, you need to give it a type, which is strange here because we're not. It's not really what we mean. Oh no, it is. We say you have to give it a type. Yeah, I guess I'm defining the fact that the semantics are column is kind of a type class. I'm saying, well, if I use column for scenes, then that's what it means. Interesting. And then if you don't have the definition of what column is, then maybe you can't use it. Yeah. Then calling it semantic maybe can be interface, but it has more meaning. Yeah, I don't know. Like maybe there's some type classes that have, yeah, I suppose it's the type class laws, right? So yeah, no, it kind of works like this, I think. So now we're saying, yeah, if you have column, then you just have multiple routes and that's it. And then maybe I might do a migration. Oops. And I say, oh yeah, migration, I changed my mind. We define, we say routes now are the semantic of plus. Such that, so now to do this, you do plus scene blah, and in fact, pretty much do just this. And what's better? Well, it's okay maybe if it's a choice, I think. So column equal, given that it will have atomic semantics, will override scene. Column equal has the semantics, and yeah. So does this mean here that we could override? There's something weird about the way that semantics are attached, because here I'm attaching semantics again to, I think this should be called atomic, and then maybe, I don't know. Yeah, I'm still not sure about all these things. Maybe it's kind of syntactic sugar for something else. I quite like the fact the correspondence to Dina there. I think that that makes sense. And then switching scenes would be another thing. It would be like modifying whatever current scene is. User 80 equal current scene, maybe play. And that doesn't need a name, but yeah, it will need to express its type, and it will just take a scene. And you will have atomic semantics such that if I say, all right, now play base scene, then it will play. All right. That's some ideas, still kind of paper-based, not translated in code, but I kind of like that. It's sort of shaping up. And as I said at the beginning of the stream, I have thought about these ideas before. Actually, I have some logs that are full of examples of trying to do this with the trig language. Let's see, yeah, here. Kind of similar approaches, lots of thinking about how to properly display these things. And so I think, like, obviously great to piggybacking on trig for, because you have a parser, but then it also limits you quite a bit in what you can do, although you have syntax highlighting and whatnot. All of these things are really nice to have, but yeah. And I've done some work trying to define matrices with columns and rows also. And it just felt like it was just a little bit too much craft, just trying to adhere to the RDF syntax. So I think like freeing ourselves from the RDF syntax might be the better idea. But obviously it means then that we have zero tooling available for us. Yeah, that's just how it is. And I'll stop right there. Thanks so much for following. This was super abstract and my head is like exploding, but it's also fun. And I feel like, all of these past year of thinking about this topic means that it makes it easier to maybe converge on a design, but we'll see whether this sticks or not and whether I can actually use it for what I'm doing on the Saturdays with the GStreamer engine underneath. And I had also some thoughts about how we could reuse this to do this idea of while you're playing live, actually building up a packaged video for YouTube, and how we could connect this. But I suppose that will be something that I pick up on Saturday's next stream. And if you want to follow and see more work a little bit like this, then connect on Tuesday for our Haskell stream, where we will continue working on, well, trying to make the NVIDIA CUDA and body accelerate example work on XOS. I still had some problem with linking the CUDA C library to the Haskell code. So I do want to do that, because that was one of the reasons why we, quit Windows and went to a sane OS. And so since I didn't get to finish this in Windows, I kind of want to get it done on NixOS until I move on to the next thing, which would be to do more fun things with the GPU, so that I get more experience in how to use it as a kind of computational substrate for some of these ideas. All right, thanks a lot, and bye-bye.